All right, one last practice problem, extra practice problem for Module 12. So this is number 10. Heating table salt and liquid sulfuric acid, don't try this at home, produces gaseous HCl, a strong acid. And the balanced equation is in your book, and I wrote it up here on the board. How many liters of HCl gas will be produced if 100 grams of H2SO4 are heated in excess NaCl? Remember, they just tell you that it's excess NaCl, so you know that the other reactant is the limiting reactant. So we use that one's number, which is 100 grams of H2SO4. Continuing reading the problem, assume the pressure is 1.00 atmospheres and the temperature is 350.0 degrees Celsius. Okay, so we are looking for number of liters of HCl. So again, liters is a measurement of volume, so we're looking for V, volume of HCl. And we know, I remember the pressure was 1.00 atms. The temperature was 350.0 degrees Celsius. So I'm going to go ahead and add 273.2 to get to Kelvin. 273, we usually just add 273, but when we have another decimal place, then we can add, remember 273 is actually, we know it can be 273.15 to add to Celsius to get Kelvin. So I'm just going to round up to the 10th place value because our 350.0 goes to the 10th place value. All right, so I'm going to be adding 273.2. So I get 623.2 Kelvin. So there's the temperature that we'll use. And then we always know R. And we typically have to solve for N, don't we, in these problems? So how are we going to solve for N this time? We're going to start with grams of H2SO4. And we're going to figure out how many moles of H2SO4 that is. And then we're going to use stoichiometry to look at how many moles of H2SO4 will produce how many moles of HCl. So we will move lastly to moles of HCl, which is our N value. Okay? So let's see. Starting with grams, I think we have 100.0. Yep. 100.0 grams of H2SO4. We're going to multiply that times 1 mole of H2SO4 on the top, and how many grams would be in 1 mole of H2SO4 on the bottom. So to figure that out, of course, you look at the periodic table, you add up 2 of the hydrogen values, which is 1.01. So you've got 1.01 plus 1.01 plus the mass value for sulfur, which is 32.1, plus 4 of the mass numbers for oxygen, which is 16.0. So add up 4 16s. And then we get 98.1 grams in 1 mole of H2SO4. So if you do that division problem, you'd end up with 1.02 moles of H2SO4. Now, one thing that I have not pointed out yet in these problems, this is number of moles of H2SO4. In N, we are looking for number of moles, but remember what we're solving for is volume of HCl. So all of these values over here need to be for HCl. So we need the number of moles of HCl. So don't just stop with the first number of moles that you come to. You have to make sure that you're in the right number of moles of the compound that you're actually looking for. In this case, we're not looking for H2SO4, we're looking for number of moles of HCl. So now we're going to find that. 1.02 moles of H2SO4, multiply it by the ratio of moles of H2SO4 on the bottom to moles of HCl on the top. Oh, excuse me, knocked over a bunch of my daughter's toys. And then we look up here, okay, for every 1 mole of H2SO4, we will produce 1 mole of HCl. So it's easy, this is a 1-to-1 ratio. So we would end up with 1.02 moles of HCl. Now we have N, we have R, we have T, we have P, we can solve for V. PV equals nRT. We'll divide both sides by the pressure to solve for just V. V equals nRT divided by P. Now we will plug in those values. So the volume for HCl is going to be equal to the number of moles of HCl, which is 1.02 moles, times R, which is a constant, 0.0821, times the temperature of the HCl gas, which it said it was at the temperature of 623.2 Kelvin, divided by the pressure of HCl, which was at 1.00 atmospheres. So if I multiply that out, I will get 52.2 liters of HCl. And that's how you do number 10. So I hope you understand these Module 12 extra practice problems, and happy studying for the Module 12 test. I hope that it goes very well. Remember, you may use a 3.5 by 5 inch note card if you are in my class. And remember to turn that in with your test. You're going to want to use all of these lovely gas equations that we've been talking about.